Okay, this is going to be my solution to the qualifying round for the Microsoft Excel World Championship. I was in the afternoon session, and this one threw me off guard a little bit. It wasn't of the same format where a case kind of builds on questions. It was just straight into doing a model with most of them. Question 1 was really easy. Got to question 2, started spending about 20 minutes on it, realised that was too long and I need to start getting some more points in. So knew I only had half of it done, but moved on to the next question anyway, thinking it might be easier. It was not. Spent another 20 minutes, tried to move on to another question instead of just sticking to something for a full half an hour and getting it done, which would have probably been a winning strategy here. And then, as always, sleeping on it, having a little think about it, you come back to it a second time and the whole thing's way easier. I think I have quite a good solution to the cards questions, so I'll timestamp everything. My solutions are a bit different to everyone else's that I've seen so far, but they work and they're quite quick, so let's get right into it. So the first question is basically asking us the cost of making these ships. So here's the price of all of the materials. Here's how many materials you need for each ship. These cells are merged, so we want to unmerge them. So all we want to do for this one is look up the ship in the list of ships, and we want to return the quantities of materials to make them, like so. And then we're going to times that by this, and we're going to times it by 1.1 because there's a markup on the ships. So that was question 1, but then we sum that obviously to get the total cost. This is why I kind of thought, oh, this case is fine, there's only 5 more questions like this, easy. Let's do the bonus as well, which is just saying what's the minimum cost to make a griffin. So I just want to pick the minimum out of these 4 columns. You can do a by row min, but I'm just going to do it the simple way. Pull that out 4 times. And then I want to say equals this times 1.1, and then sum it all up again. So there's our answer. Okay, question 2. This one is a little more involved, a lot more instructions. So I kept reading these instructions, wasting a lot of time thinking that the dwarf loses HP as he moves through the mine, but he doesn't. Essentially, I'll use this one with the symbols, I don't need this one, let's delete that out. Essentially, he's going to pick a row, so if it's row 2, he'll always move along to the right, go down, then move back to the left. So let's move out this stuff that I don't really need. So basically what I want to do for this one is I'm going to make a copy of this. Just call it M for map. I don't need this. So I basically want to make myself an odd map and an even map. So for an even map, the first row is always going to go to the left. And then I basically want to reverse my second row. So I'm going to say index of this row. And then I'm going to pick sequence of 39 because it's a 39 by 39 grid. And I want to start at 39. And I want to go in steps of -1. And what that's going to do is it's going to give me this in reverse, as you can see. And then all I do is pull these 2 formulas down, and you'll see the formula swaps every other row. So even rows are the correct way, and then I snake down. That means when I 2-col this map, it's going to be the order that things would be collected in. So I'm just going to copy paste that into here. So this is now my even map, and then my odd map is literally going to be everything reversed there. So all I'm going to do is take that formula I already did to reverse everything, and then I have my odd map. So I mean, that's pretty quick for me. And then I'm going to say flatten, which is one of my lambdas that just is 2-col of this plus its addresses. And then I'm going to flatten, flatten my odd map. And then I have my two orders. So I'm going to call that even map, even MP. I'm going to call this odd MP. And then the question should be pretty easy. So let's go back here, delete all this out because I don't need it. And then I'm going to do a data table. So I'm going to say example 2. And then we'll look it up in here and pull out G. And then all I want to do is say if is even this, then do even map, otherwise do odd map. And then I have my order. I didn't explain this question very well, but I assume if you're watching this, you've already tried it. I want the rows of this, so row of indirect of this. I also want to know the value of the thing, so I'm going to say xlookup this in here, give me the value. And what else do I want to know? I want to know if the item is toxic, so I'm going to say or this equals mercury, or this equals uranium, because those are the two toxic ones. I'm going to wrap that in a minus minus. So what you see is I'll have a 1 where anything is toxic. And now let's kind of get this question solved. So basically I want to filter my table where the row number in my table is greater than or equal to the specified row in the question. That's going to then just give me only the rows in order that things will be collected. Luckily the example starts from 2, so I can fill in all of this stuff, and it's the maximum size it will ever be, so I won't ever miss anything. So I'm going to get a cumulative value of treasure, so the first one's going to be that, and then the next one's just going to be this. I could have done this with a scan as well, but that's fine. And then I want to start at 100 HP, and I'm going to lose 1 HP for every time this is a 1. Once I'm carrying 2 mercuries, I'm going to lose 2 HP every turn. So all I'm going to say is equals the sum of this, and I'm going to put a colon there so that every time I drag this down, it starts to capture all of the things that are toxic. So here I'm going to capture a 1, here I'm going to capture a 2 because I've already got 2 of them. So I'm going to do the number above minus that, and that is going to be my health basically. The only problem is where there's a gap like this, no time elapses. So he doesn't lose any health because he actually has the health of the cell above. So I'm going to say, first of all, if the value equals 0, then do whatever the health was before, otherwise do my original formula. That should then work, and then all I need to do is xlookup 0 health in this column, return the cumulative value, and I want next match or smaller item. And you can see the example answer is there, so we just data table that, and we should be done. I think there'll be one error where it gets to the edge of the map, if I'm right from my practice earlier, which there is, which is 36, so let's just put in 36 to show you what happens. He gets to the end of the map, so actually he collects all of these treasures here. So all I'm going to do is I'm just going to, put in my xlookup. If it's not found, I'll just do the sum of all the treasures because he gets all of them. And then, yep, we have our answers. Now I've got my answers in for question 1 and 2. I kind of want to just keep this spreadsheet running smoothly, so I'm going to delete out this tab because I just don't need it anymore. Oh, actually, yes, I do, because there's a bonus question. So the bonus question is, what's the value of all the coins in the mine? So I can just do the sum of xlookup all the stuff in the mine in here, return here. And whatever that number is should be my answer. Yeah. Okay, so let's delete these tabs out because I don't want this spreadsheet running too slowly. And now we're on to darts. So I'm actually going to do the bonus first because it will make the question quicker. So I'm going to say equals unique of 2 col of all of my darts. So this question is basically you're running a darts game with the normal rules of darts, but you don't have to end on a double. So you just keep throwing until you get to 0. If you get to 0, you win. If not, you go back to your score from your last throw. So here's all my unique darts. Then I'm going to say extract numbers, which is a lambda I have of all of this. So it's going to pull the numbers out. Where it's an NA, I can see just visually that that's a bullseye. So I'm going to say if there are, then it's worth 50. And then I'm going to say substitute this with that and replace it with nothing. So that's going to now get rid of my number from everything. Then I'm going to do unique of that. So those are all my multipliers basically. So I know triple is multiplied by 3, double is 2, single is 1, bullseye is 1. So let's copy that as values. And then I'm going to xlookup that in, oh, it didn't copy his values, so let's just sort that out. Oh, it's because it's down to there. So yeah, now I'm going to XLOOKUP that in my multiplier, you know, name, and get the value. So I'll have one error, which is because this doesn't have a number in. I mean, a letter in. I could have changed it, but I'll just say, you know, if error, it's a 1 basically. So now we have our values, we have our multiplier. So we're just going to times that by this, and we have the value of every dart throw in our games. So let's do the bonus first, which is looking up all these points. So all I'm going to do is say sum of XLOOKUP again. So I want to look for all of this stuff in here, return here, and that's the sum of all of the darts. Let's copy these values. I'm also going to copy this as values, remove this, and I'm ready to do my data table solve. Example 3, let's look up this in here, and it's B, and we want, what do we want? I think we want G out to DV, G to DV. So I'm going to say wrap rows of this, oops, by 3. So what this is going to do is going to give me players 1s, throws, players 2s, throws, players 3s, throws, and so on. But I'm going to XLOOKUP all of that in here and give me the actual value, because I don't, you know, this is easier to work with. Then I'm just going to kind of do myself a player 1 score and a player 2 score. So we're going to start at 501. I'm going to put it in this column. You'll see why. And I'm going to say equals 501 minus this. And I'm going to say equals this minus this. And kind of that's my score. And then the next turn is player 2's go. So it's just going to equal this. I'm going to lock it in J. So then when I drag that across, it's just there. Now, one thing I need to correct is if the score goes below 0, I want to revert back to that 501. So let's just say if this is below 0, then give me 501. Otherwise, give me my initial thing. And that's a bit better. Now for the next throw, again, if I go below 0, I want to go back to 501. But if the throw before also went to 0, then I want to go back to 501, because there's 2 ways I can get back to 0 here. So this will be the longest formula in this solve, and then it's just a case of dragging down, as you'll see. So first I'll check if we went back to 0. So I'm going to say if this equals this, and I'm going to lock it on column J, then do this. Otherwise, if you know, my normal calculation is less than 0, do this. I'm going to lock it to there. Otherwise, give me this thing here. And that should just drag across, and then I'm pretty much done. Oh, I didn't lock one of my J5s, which was this one. Okay, that's player 1 done. So now the order's going to be swapped. So I'm going to put this formula up here. I just need to move this cell over to the last score from player 2. So that's done. And then I want my formula here. But again, I want to move what I'm minusing off to be here. So I should have that minus that. And then here I want this, 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 and then drag that across, and I should be correct. So this is my player 1 score for each dart, this is my player 2 score for each dart. we can see that player 2 hits a 0 in this column here. So what I really want to do is look up where there's a 0, and X look up where there's a 0 and return the other player's score. So first of all, I want to know who wins. So I'm going to say X match 0 in here. I'm going to say, is that above 3? Because if it's above 3, then it's player 2 wins. So we see here it's true. So I'm going to say, if that, then P2, otherwise P1. And then what we'll see is we get a P2. Now what could happen is P2 could hit 0, and then later down here P1 could hit 0. But what I'm going to do, I'm just going to 2-col this whole thing and get rid of errors, so it's going to give me the first thing up here. So I'm going to say 2-col this, comma 3, and whatever's in this cell is going to be the winner. So I know it's P2 wins. Now I basically want to say if this equals P2, then X look up P2 in here and return player 1's score. Otherwise, I want to X look up P1. God, my typing is terrible. P1 in here and return P2's score. And that should be my answer when I data table everything. Okay, so that's darts done. Again, I'm going to now just delete this out because I don't need it. Now we're on to cards. Again, a load of rules. I think people struggle with this one, and I can see why. There's just a lot of rules, but essentially the game is you get 52 cards. Anytime you match 3 of something, so if, 3 queens, you take them out and you get scores for them. So queens would be worth 15 each, and then you multiply that 15 by the suit, multiply the 3 queens together, and that's your score for eliminating those cards. Let's do a little bit of setup. I want these to all be 1 character, so I'm going to change 10 to a 1, and I'm also going to change anything in here that says 10 to a 1. So let's do find and replace 10 with a 1. There we go. And then we're set up, ready to go. So let's build this out. Example 4. X look up example 4 in here, B, and then we want G out to BF, G to BF. And then I'm going to do this over here. So I'm going to say equals 2-col of my cards. And then I want like an accumulated value. So I'm going to say that and whatever's above. So this is going to be like my running deck. So, I get 2 queens, then I get a king, so on and so on. Just put that down to the end, and then I'm just going to put that in, align it that way so it doesn't take up too much space. And now I want to build out a list of all possible combinations of 3 cards that will get eliminated from here. So let's do a sequence of 13 columns. I want to start at 2, and then that's that. Let's pull in this table over here, because I'll need it later anyway. Let's just put the suits here, and then I'm going to say equals this and this. So now I have all possible cards kind of listed in groups. I'll change those 14s to aces and 13s to kings later when I'm done. I also want my sequences of runs, so of like 2s, 2, 3, 4, 4, 5, 6, so on. So that's going to be sequence rows again, 13. 13, I want to start at 2, and then I'm basically just going to go bam, and then I'm going to start this one at 3, and I'm going to start this one at 4. So this is going to be all my runs. Okay, and these runs, they have to be of the same suit, so I want to replicate this 4 times with those. So let's just copy this as values for now. I know this is a bit tedious, but once I've set this up, the whole question is going to be really easy. And then I want to say equals this and this, and I should be able to copy that every 4th cell down. and I have all of my suits again. So that's all my runs. Let's copy those as values. Get rid of these runs just to clean things up a little bit. Copy those as values. And then, yeah, let's get rid of all my junk here, my sequence junk that I've been playing with. So these are some of my possible combinations. I'm actually just going to now change 10s to 1s. I'm going to change 11s to jacks. I'm going to change 12 to queen. I'm going to change 13 to king. And I'm going to change 14 to ace. Okay, and then on my runs, actually the first we can go is ending at an ace, so it's going to be, that's all my possible runs. And then for my possible sets of 3, I just want to remove 1 suit each time from that. So let's pull that out the way. Copy this. So I'm going to remove the top suit, then I'm going to remove the second suit, then I'm going to remove the third suit, then I'm going to remove the final suit. So then if I close these gaps up, you'll see I have, now I have every possible set of 3. So I know that's a bit tedious, but let's now put these all together. So I'm just cutting and pasting these here. Oops. Nearly there. Okay, finally. So this is all my possible like runs and 3s that I can get rid of if you like. So let's just move them all to the top for a second, about there. Now, basically what I want to do is I want to find whether these things are in here. So I'm going to say equals search for these 3 things in my string, and I want to lock that on the rows, and I want to lock that on the column, and then and what you're going to see is an error because they're not there. So I'm going to say is number, and I'm going to wrap that in a minus minus. So then what you'll see is as I drag across here, whenever I get a queen, like here, so queen of diamonds, I'm getting a 1. So I'm going to sum those up. And basically, whenever I get a 3 in this place, it means I have the set. So yeah, let's drag that all the way across and you'll see what I mean. So let's go to the bottom here. So at the bottom I should have every card, so everything's a 3 because I have every run. So all I'm then going to do is I'm going to say equals filter this, and I'm going to lock it where this equals 3. I'm going to call that. Something went wrong, my call bracket didn't open. And then if error, I am actually going to say if empty, just give me blank. And then what you'll see is, so they spill, but as I get down here I get lots of cards. Now sometimes cards will be used twice, so it could complete a run or a set free. So you see this queen here is duplicated. So what I actually want to do is do unique of that. I'm going to do it up here, unique, and then I'm going to concat it all back together. So it's just going to be a list of all the cards that I can take out. So I can take out queen, queen, queen there. Here I could take out queen, 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 king, ace. The only thing is, because I can take something out, I am going to take it out of this string. So you can actually text split on multiple things. So I'm going to split that into multiple parts. So I'll just show you out here how it works rather than typing it all in one. So it was mid this sequence of the length of this over 2. because I'm taking out 2 characters at a time. So I want to take out 3 things. So the length of that's 6. I want to take out 3 things. So that's what I have to do over 2. I want to start at 0. I want to do step of 2, and I want to take up 2 characters at a time. So what you're going to see is this, and then if I basically were to say text split this thing on this array, because you can text split on arrays, I'm just going to get ace king and then blanks. So I basically just want to concat that back together and I get my answer. So let's do that in here. So my sequence is going to be text split whatever we have by the mid of that sequence length of that over 2, 2 characters of 2. That is done, I think, and then I want to concat that back together. Concat. So there we only get ace king, so it's removed. Now when there's nothing to remove, you'll see it results in an error. So for this error, I'm just going to say if error, then I want my original string, my original method to get the string, and then that should be it. So let's drag that all the way up, drag it all the way down, and that looks correct. I'm just going to refresh everything because it seems to be not pulling everything. So why is that? I have some freeze here, but it's not. Oh, I haven't dragged this down. There we go. That was silly. Right, so I've got all my things. Now I just need my points, so I'll do that in here. So for the points, I'm going to say, I'm going to split this into its component cards again. So I'm going to say mid this sequence len of this over 2 to, so you'll see that splits to there. And then I want to do left to just get the card. That's just going to give me the queens. So I want to X look up those in here and return the card value. So that's my card values. Then I want the same thing but on the right side and multiply together. So let's times that by the same thing, but I'm going to take the right and I am going to look for the right side in here and return here. And these are actually, you know, that is 3, 5. There isn't an X in there, so I don't need to remove that. So that's my score, and I basically want to times them all together, so product of those. That's my score. If I come down, there's an error because there's nothing there. So again, I'll just say if error blank or 0. Let's just do a blank. So let's drag that up, drag that all the way down. And the ones with numbers aren't being recognized because these are formatted as numbers and these are formatted as text. So let's say equals these and you know, blank space. Copy that over here. That's converted them to text. And that's it. My answer is the sum of all these. So let's just say sum of these. And then put my data table in. Boom. And example 4. It's taking a little while to calculate, I think. Yeah. There we go. Hopefully that's my answers. Lots of processing power. And it is. We can also do the bonus. So the bonus is asking like to sum up the value of all the cards that are left. So it's this string. I might actually get a value here. So what I'm going to do is, if I had a value here in the last row, I'd take it out and get a new string. So I'm just going to copy these down one more time, and I'll take that one. So equals that, and then I'm going to, oh actually I'll put it here, because I've done my answers. Refresh my data table. Do a data table again, I might need to press it again. So example 4. Again, it gets really slow at that number 70. Now for this one, you just add up the individual value of all the cards. So I'm going to concat all of this stuff. I'm then going to do my mid trick, this sequence length of this over 2. So I've got all my cards, and then let's do Let's just do this to get the score. So I'm going to put, I'm going to move the things here. $180, take that down, and we get 10,513. So let's put that in. 10,153. Did I write something wrong? 10,513. 10,513. Okay, so that's the answer. Okay, to Lana Banana, this bonus, how many bananas are in the garden? I can just literally, you can do that and it'll tell you 279 in the corner, so 279. And then for the Lana Banana question, I did figure out a solution that took about half an hour, watched Dim's solution, and it was way easier. So rather than me just copy his solution, I would say go and watch his video how to solve this. Just to briefly explain my original way, I tried to use a lambda I have, so I said closest on map. My cell is, I don't know, this, and my map is this banana garden. And basically, oh, I need an extension, so I'm going to say 39, because it's a 39 by 39 grid, and that's going to just give me everything, you know, that's in the map, the cell, you know, the rows, the columns, and the distance. So this is always ordered in distance. What I don't have in this lambda is it's not then ordered by the lowest row number, the lowest column number. So yeah, I eventually made a massive let that kind of eliminated my, filtered out my cell addresses that had already been visited, checked whether an edge or a banana was closer, and I got there in the end, but Dim's was way more efficient. So I would go and watch that. I'm not going to do it here because it's just a carbon copy of his video. I think my solutions were quite straightforward and easy to follow. Hopefully they were. If not, let me know if you have any questions. But yeah, learnings from me is I should have actually stuck out like some of these questions that were taking a little bit longer and seen them through to the end instead of jumping around this case. So yeah, hope you enjoyed. Give it a like and subscribe if you did, and hopefully that was useful.